For my third example, I'm going to graph the system of 4 inequalities. And notice that they're not written in slope-intercept form, so they need to be rearranged so they'll be easier to graph. In each example, I'm going to subtract x to rearrange the inequality. In the first problem, my inequality becomes y less than or equal to negative x plus 3. In the second one, I subtract x, and my inequality becomes y greater than or equal to negative x minus 3. In the third problem, I subtract x, and that gives me negative y greater than or equal to negative x minus 3. When I have a negative here, I'll have to multiply this equation by negative 1 to change the sign. And with an inequality, I also will flip the symbol. I'll change the signs of each term and flip the symbol. So this is equivalent to y less than or equal to x plus 3. And that's true of this last one as well. I get negative y less than or equal to negative x plus 3. And when I multiply that times negative 1, I get y greater than or equal to x minus 3. So these are the inequalities that I'll graph. With each one, I have an equals under my inequality symbol, so they'll all be solid lines. First, I'll graph y less than or equal to negative x plus 3. My y-intercept is 3. My slope is negative 1. And my solutions are less than this line, so I draw an arrow down under. Next, I'll graph y greater than or equal to negative x minus 3. I go to y is negative 3. It's my y-intercept. My slope is negative 1. This is a solid line as well. But since I have a greater than, my solutions are above this. My third inequality is y less than or equal to x plus 3. So my y-intercept is 3. My slope now is 1. And my solutions are less than this line. And this last inequality, y greater than or equal to x minus 3. My y-intercept is negative 3. My slope is positive 1. And my solutions are above this line because it's greater. Where all the arrows point, this diamond should be my solution area. But you can check a test point and make sure for each one that the inequality is true. Is 1 less than or equal to negative 1 plus 3. works for the first one. Here's my second inequality. Is 1 greater than or equal to negative 1 minus 3? Yes. And here is 1 less than or equal to 1 plus 3. Yes. And is 1 greater than or equal to 1 minus 3? Yes. So here, where 1, 1 is, that's where my solutions will be. I describe the solution by stating the domain and range. My domain is from negative 3 to 3. And since my boundaries are solid lines, I use brackets. If I wrote that in set notation, I would write the set of values x such that negative 3 is less than or equal to x is less than or equal to 3. For my range, I need that also least to greatest. So that goes from negative 3 up to positive 3. And in set notation, I would say the set of values y such that negative 3 is less than or equal to y is less than or equal to 3.